Hey, everyone. It's Blockchain Bernie here, broadcasting live from fabulous Las Vegas. Random access storage on the blockchain. That's what we're going to talk about today. And it is really new. It is absolutely new. I'll go through everything with you on what's available today on other blockchain and crypto projects out there that are doing something related to storage, and it's really, really different from random access storage. All right, so let's dive into it. Let's look at three different things, right? Archival, and then file storage, and then random access storage, right? So let me give you that roundup here. Archival is you write a file sequentially from beginning to end. You cannot go back and look into the file at an earlier position inside the file or something. You just write it once, and then it's like on Archival, it's write once and then store it forever. And it might be difficult to even get it back because the read operations are supposed to be rather infrequent in the case of archival, right? When we archive something, we don't expect it to need it back, every minute, right? Or once a minute. We just expect, well, there might be a situation weeks from now, months from now, years from now, where I might want to read it back. And if it then takes a while to get it back, that's fine, right? So that's archival. It is very different from file storage. And file storage, what I call file storage, you all know it from, back in the day, if you're old enough, there was Napster, and now there are all those BitTorrent protocols and stuff, and you can share files. And files mostly are movies or songs or stuff like that. These are all files that don't need random access, right? So within a movie or a song, you can position somehow, right? But it's not like you're specifically interested in that 2 gigabyte movie in everything from byte 3,595,708. And then from there, you read the next 1,024 bytes. You're just not interested in that if you're only file storage, right? You're sharing files with like media files or something, and you don't need random access there, right? So those are a lot of platforms, right? Like Filecoin, Shadow Drive, all these, they are mostly concerned with file storage, right? And by the way, in file storage, you might be able to override it, right? In archival, you cannot even, you just write it once and then it's there. You can't even change it anymore, right? And that's even a feature, right? With archival, you want to have it, just written once, right? And then there are no changes that can be made. With file storage, it's different, but then think about random access storage, right? And random access storage is something that is very familiar to so many programmers that write apps on the internet, right? And I call these apps web2 apps, right? They are web apps, right? And these web apps have databases, right? How are these databases implemented on these servers? Well, most of these servers run on Unix operating systems, right? Linux is a flavor of Unix. So within the Unix file system, there is a file, but these files in Unix, they are completely random access, and they have been since the 70s. So you can really write gigabytes, terabytes of data into the file, and you can position the read-write head on any position in the file, and then you can read from there the next 768 bytes, and then you can overwrite on that specific position, right? And that's what makes databases possible. And we need data, when in all Web2 apps, we need databases to store customer data, right? All your customers, all your orders, all your payments and whatever, it needs to go into databases, and databases need random access storage, right? It is so basic in order to get a revolution of all different sorts of apps. And if we get these apps that are all possible, have been possible, on regular servers without blockchain. They have been, so Unix is there since the 70s, right? So since the 70s, we've been able to write apps that can use random access storage, right? And it's just not possible today on the blockchain with all these storage projects that I mentioned to you. There is no random access storage. And what does this mean for Web3 and Web3 adoption? But before we dive into that, I would like to ask you for a small favor. Just hit that like button. By the way, you're also getting points for that like button in our Xandeum points program. We're building that scalable storage layer, random access storage layer for the Solana chain. We have a points app, so each like, each comment, and stuff like that will give you points there. But I would appreciate it anyway, just because we want to get the word out, right? And I want to discuss with you in the comments what you think about random access storage, right? Do you know any other projects on the blockchain and within the Solana ecosystem especially that's working on random access storage? I would love to know, right? And discuss these projects to you, the differences of what we're building in Xandeum towards any others. So you just heard how it's different to Filecoin, which is just a pure file storage, right? And that's underscored, by the way, in Filecoin by what they call content addressing. So there's no file name, right? The file name is a hash of the contents, and then you access it by that, right? So that basically prohibits changes to the file, because if you change the file, it would be a different file. It has even a different name because the name is the content, right? For databases, for storing customer data, you need a file name that doesn't change, right? The file name is mycustomers.db or something, right? And then you want to make changes to it without, it suddenly being another database or something, right? So we want that familiar programming model that millions and millions of Web2 programmers, and even before the web programmers, client-server programmers, have been used to, right? And bringing that familiar programming paradigm to the blockchain, and it just hasn't been possible as of today. We feel that is quite revolutionary. That's why I'm so excited to work on that scalable storage layer, random access storage layer. We do paging, right? We borrow so many concepts from the Unix file system, right? All files are being cut into pages, right? And pages is a fixed size chunk of data, right? And these chunks will be sent to our PNodes. Those are the storage provider nodes. Those are offloaded from the validators, from the Solana validators. The Solana validators oversee the PNodes, the storage provider nodes, and we have many, many of these storage provider nodes, and all the data is only stored on a certain number of these PNodes, not on all 100,000, right? So an app can say, I want to have it on 17 different PNodes because I want a redundancy of 17, right? Other apps might need higher redundancies. Other apps might be okay with lower redundancies. And then the validators offload the actual storage to these PNodes, 17 of them, or whatever the number the redundancy might be, but not all of them, right? And that's how we achieve that scalability. The validators oversee those storage nodes. They send them cryptographic challenges all the time to make sure that they do their job and they store what they're supposed to do. And yeah, this will kind of complete what we can do with blockchain smart contracts, right? Because right now we can do compute and we can do RAM, right? That's random access memory, but memory is different from storage, right? How is memory different from storage? Memory means you have it really, really fast. You can access it as fast as the CPU can go, but it's relatively limited in size, right? You have that with any other normal computer as well, right? And what we need is the random access storage layer that is scalable in capacity, scalable in storage capacity. And Solana at this time is scalable in so many ways, but the scalability is missing for the storage capacity, right? The Solana accounts model is their storage, and it's awesome, and it's very fast, and you can store quite some data there. But even if an app just needs a gigabyte, right? And think about a customer database of about a gigabyte, that's rather small, huh? And then it starts getting prohibitively expensive to store that on the Solana chain, simply because the Solana accounts are being stored on each and every of the 2,000 something validators that the Solana chain currently has. And we hope the number of validators will grow in the future. So many validators all need to store that, and you can't do terabytes and terabytes. And think about, we have 1,000 apps and each one needs a terabyte of data. That would be so much data, it just can't be handled in the Solana accounts. So we need a scalable storage layer. So that's why we're so happy. If you haven't heard of Xandeum, go to Xandeum.com, learn everything about us. There's a lot of documentation out there, and we're in the process of building it. And, I think it is really, really exciting stuff, and it's about to revolutionize the blockchain world. Let me know if you agree. If you see anything different than I do, leave me that comment and subscribe to my channel if you haven't already done so. But for now, thanks so much.